Here we go, guys. Section 2.2, packet lesson. Solving what's called combined inequalities. That just means multiple inequalities, and that's what we have. So hopefully you watch the pre-lesson. It will really help you out a lot. So don't try to figure this out without listening to that pre-lesson, or else this is just going to confuse you. So really what we have to do is look at this, and I see the number line is way down here. I'm just going to go ahead and draw a new one right here. X is less than 2. So there's my 2. And I'm going to go open circle to the left. And x is greater than or equal to 1. So there's my 1 right here. Fill that circle in because it's greater than or equal to. And it goes that way. Don't forget, the word and means look for what's in common. Or where do these graphs cross? And that's everything in here. So I could say that because these cross, and I've got this space in here, I can say that x is greater than or equal to 1, but less than 2. That expression, or combined inequality, is saying, hey, what we're solving for can fit in between here and in here only. Why not out here or out here? Because it's not in common. All right, let's go on to this. Or, draw the drawing. And there's my 0, says x is less than 0, so it's open circle to the left. X is greater than, or there's my 1, filled in circle up to the right. Because it's or, I'm just trying to figure out how to most simply state everything that's in my picture here. So it's the sum of all the parts. Well, because there's two different parts, I need to say x is less than 0, or x is greater than or equal to 1. Strangely, your answer sometimes is the problem itself. Very unique. In the pre-lesson, I shared with you that if you see something written like this, it is definitely to be implied or thought of as an and problem. Now, I didn't show an example like this in the pre-lesson, but what you need to do is turn this into two situations. So I'm going to take this part off, and I'm going to write it as this. But I know it's an and problem. And then what I'm going to do is I'm going to mentally think about the other side. And that is right here and right here. So it's and then I look at this side, 2x plus 5 is less than or equal to 15. So there's a little tricky problem right off the bat. So I'm just going to get solving here. So subtract 5. So I get negative 2 is less than 2x, divide by 2, divide by 2. And so I like to flip these around. So I get x is greater than negative 1. And, in other words, I got to investigate this side. Subtract 5, 2x is less than or equal to 10. Divide by 2, divide by 2. X is less than or equal to 5. Now, if I look at this on my drawing here, go ahead and draw a drawing. Here's my 0. I like to start there. Here's my negative 1. I'm going to draw this one. X is greater than negative 1. But this is 5. 1, 2, 3, 4, 5. That's a filled-in circle. It's going to go up and to the left. And again, because it's an and problem, which we knew because it was written like this, see, there is no and there is no or. We know that that's an and problem. It's just a rule. So we know we have to look for what's in common, and that would be everything in here. Now, when you have a situation like this, you stick the x in the middle, and then you go to the left, and you think, oh, x can be greater than negative 1. And then you move to the right, but it needs to be less than or equal to 5. If you just think of temperature, it's like, hey, if I told you outside it's warmer than negative 1 out, but it's colder than 5 degrees out, but it might be 5 degrees, this is how you would explain the temperature. Okay. Once again, we have the same situation here. Because there is no and or written in the problem, it's an and problem. We break it up into two pieces. That's my left side. You got to insert that word because that helps your brain function. And then I look at this side. Negative x plus 3 is less than 4. Now I've got two inequality problems to solve. So here's what I'm going to do. I'm going to add x to both sides, but I'm also going to add 2 to both sides. And this cancels, and I get x is less than or equal to 5. And bring that along for the ride. I'm going to subtract 3. I get negative x is less than 1. Now, watch this. I got to multiply this side by negative 1, multiply this side by negative 1. X is, what do I got to do to the inequality when I multiply by negative? I got to flip it. If you don't remember that rule, the whole problem is going to go down the drain. Now I'm going to go ahead and use this little graph because it will save me just a smidge of time. Here's my 5. This says x is less than or equal to 5, so it's a filled in circle, sorry, to the left. This says x is greater than negative 1. My negative 1's down there. Open circle to the right. Okay, so once again, we have this situation, which it's looking like a lot like this one, isn't it? So our answer is x can be greater than negative 1 and less than or equal to 5. Okay, now we're going to get into a couple of OR problems. So here we go. And I got plenty of time, I think. So we're going to subtract 7. Kerchunk, negative 2y is less than or equal to negative 6. Now here I have to divide by negative 2, divide by negative 2. Don't forget to flip the inequality. There's part of it. Don't forget the magic word, OR. Now I got to solve this guy up here, so I'm going to add y to both sides. Subtract 10 from both sides. I'll just write it up here. And then I got a Kerchunk bar, getting a little messy. I apologize for that, but 3y and y is 4y. Gone. Less than negative 10 plus 4 is negative 6. Now this one's going to be a little weird. So I divide by 4. My phone's ringing. I apologize for that. Y is less than, I got to reduce this, negative 3 halves, which is just the same thing as negative 1.5. So if I start here and I think, okay, there's my 0. I'm going to just say this is my 3 from here, filled in circle, and y is greater than or equal to 3, so it goes that way. Where's negative 1.5? Well, that would be somewhere over here. Negative 1.5. Open circle, because it's strictly less than. And then y is less than, so it has to go that way. How do I answer that in the world of OR? Well, I have to explain this portion, and I have to explain this portion. How do I do it? To be honest with you, it's right here. So sometimes it's just sitting right there for you to take. All right, let's go on to this one. A little different. Add 1. 2z is less than or equal to 6. Keep going with this guy. Z is less than or equal to 3. Add 5. I get 3z. Someone needs to talk, but I got to finish this lesson. Is less than or equal to 15. I don't know if you guys can hear my phone ringing or not, but all right, so divide by 3. Z is less than or equal to 5. Now, this is an OR problem. So I'm going to put my 0 here. I'm going to take my 3. Notice I'm filling it in because it's less than or equal to, and I go that way. Again, less than or equal to 5, so I'll put that one right here. Goes that way. It's an OR problem, so I have to, with the simplest way possible, explain what's going on here. And I can explain it by saying z is less than or equal to 5 because this one covers this one. And that's what you do in the world of OR, and you have a picture or situation like this. All right. Now it gets a lot easier, I think, because they've done all the math for you. So all I need to do is look at this. X is less than or equal to 0. I'm going to put my 0 there. Filled in circle because of the less than or equals. That means it includes 0, and I go up and to the left. x is less than or equal to 3. My 3 is over here somewhere. And that's less than, so that goes this way as well. Here's the key, the word and. That means you got to look for what's in common. How do you know if there's something in common? It's where the graphs overlap. And that would start here, and it would move this way. You see how that's all in common? And it would go that way forever. How do I explain this space? I say x is less than or equal to 0. There it is. Now, some of you would be able to just look at this, and if you read it, you might be able to go from here to here because your brain just paints this picture for you. If that's true, go for it. But I'm going to show my work. X is less than 3. I'm going to put my 0 here. I'm going to put my 3 here. Notice I left it open because it's not equal to. So it's less than 3. X is greater than or equal to 5. So 3, 4, 5. I'll put the 5 over here. It's filled in, and it's up and to the right. Again, because of the word and, we're looking for what's in common. We're looking for where the graphs overlap, like over here. Didn't happen. That's our classic nope, empty set. This one, x is greater than 0. There's my 0, open circle to the right. And x is less than 2, so I'll put my 2 right here. And that is right here. All right. But here's the word, or. What does that mean? It means look at the picture and try to, as simple as possible, explain everything that's covered. Guess what? Everything is covered. Another way of thinking it, there's nothing that's not covered. So that's an all real numbers situation. That finishes 2-2. Keep working at it, guys.